This is the second part of visual scripting in Unity tutorial. If you haven't yet seen part 1, watch it now. In this part, we will concentrate on the collisions between the monster and the fruits and all the exciting stuff that happens after a fruit gets smashed. To detect collisions, we need the third entrance to our graph. What I mean, we already have onUpdate, which I can zoom out this, and even I can maximize the window. So we have the onUpdate flow, which leads to falling down movement and wrap movement. So the two operations that we need in this part. We also had the onStart node, which led to setting the screen size, and now we will create the third entrance, which is called onTrigger enter 2D. OnTrigger enter 2D is a function automatically called by the framework when a triggering event, so collision between two objects, starts. So one object is entering the area of another object. We could also have another event function for staying in the triggering situation and exiting, but we need enter, and because we are programming for 2D, this is onTrigger enter 2D. So that's our new node. Let's change the scaling. Change of the scale, so making the graph bigger or smaller, can be obtained by using the roller in the mouse with the control button pressed on the keyboard. Let's make the window the more handy size. Move this a little bit to the left, and we are ready to start now. So what we need to do when the trigger enter situation or event is detected, first of all, we need to reset the position of the fruit. Then we also need to increase the speed of the fruit and increase the score of the game. Resetting the position is placing the fruit back to the top of the screen, but this time using a random value for the x-coordinate, so the next time over the fruit starts at a random position, so it looks like a new fruit dropped into the screen. But because we do any of these three actions, what I really need to do is to check if the collision was indeed the collision with the player. It is possible that two fruits would collide, and we don't want to see the score increased just because my apple crashed into a cherry. Okay, it's only when the monster is crashing the apple. So we need a way to distinguish the player from other objects in the game, and to achieve this, I select player and go here to the tag. This is such a standard situation that actually Unity allows us to provide a special tag on the player object just to say this is the player object. And now the first thing that I will do, what the graph is, that it's the player graph, sorry, switch to the player graph because I selected the player. Okay, sorry, back to the Apple onTrigger enter 3D. So this function onTrigger enter 3D has the flow, of course, and also the collider input. So this trigger, this event will come with information about the collider, so the colliding object. This colliding object for the fruit, we are in the graph for the fruit, so the collider will be the player. So we need, first of all, to get the tag of this collider, tag component game object, we have a special function here, game object compare tag, which I think should be working well for us. And the tag will be player. And now I need a node if okay, this should do. So if the tag of the collider is player, then something should happen. I will here on the true, I will attach my favorite node sequence. I will tell for a moment that it only has one step, and let me try something didn't work. Oh yes, of course it's quite tricky, but to see the debugging information in the graph, we actually have to select the object in the scene hierarchy. And now it should be clearly visible. Not so easy to, yeah, but you could see the control bubbles when we are colliding with the apple. So tag testing is working. Let's tidy this up a bit. Okay, the next stage will be increasing the speed, not because it's so important or the first thing to do, but just because it's easiest thing to do. So we will change the speed. So the speed is here by setting its value. Okay, so I will send the flow here so that the variable is indeed set, and this new variable, the new value of the speed should be the previous value of the speed plus, so for the first time we will use the add node, and add quite funnily doesn't have a space to put any value here, therefore I need a new node, add node. If you need a value, a constant value, it's called in programming languages literal. So I will take float literal. Okay, and we will add 0.5 to the speed and set the speed, this value, as the new value of speed. Right? Smash, and it's faster and faster. You can also, sorry, it's not clearly visible here, but we change the speed from 1 to 9.5, so I will restart the game again, and please note speed 1 now is 1, when I smash it is 1.5, 2. Okay, so each time I smash it, the speed is faster and faster. So another feature of this program works. I can now put it into the frame, call it increase speed. The next task will be to reset the position of the fluid after it gets smashed. So the control from the second part of our sequence will go straight to a node that we already know, set position, transform set position. Set position requires a vector 3. Usually we build graphs from the left side to the right side. This time I will build this graph kind of backwards, so from the right to the left. Set position needs the value. This value is vector 3. So let's build vector 3 out of our familiar create function, which will again be xy version because z as always needs to be 0. Now the y value is quite simple because this is the height, the top of the screen, which already is known for us. It's the variable width. So two things to notice here. First, for the y coordinate I should have rather taken the height, not width. I hope this mistake will be fixed later on. The second, both width and height are the variables that have been added to the project in the final segment of part 1 of this tutorial. If you don't have these variables, you can replace them with fixed values like 5 for the height and 10 for the width of the screen. The variable width gets one more application here. Okay, it's done now. The x value has to be random. So building still to the left, random. We have a few random related functions, but this looks good. Random range from inclusive minimum to maximum inclusive maximum. These two versions differ only marginally, but I think that inclusive is good for us. We need the minimum value and maximum value. This is the value for the x coordinate, so the minimum will be the width of the screen, negative width of the screen, and the maximum value will be the positive width of the screen. I'm just realizing that these names width and height may be a little bit misleading because what we really have is half of the width and half of the height of the screen, because the coordinates, the screen coordinates range from, in terms of x coordinate, ranges from negative width to positive width, and the y coordinate ranges from negative height, which is -5, to positive height. Okay, so we can now take the width variable to get a negative for the minimum. We will once again use the formula. Formula will be -a, one input. This is the width, so we have negative input. It goes as the minimum value, and the value, positive value, goes as the maximum value. Let's test the solution. Smash, and the thing disappeared. Now it's here. Smashed, and it disappeared. Something strange is happening with this apple, so let me try to find out. I will move it a little bit. It looks like initially it gets value of 10 because by mistake I put the width of the screen as the y coordinate, and it should be height of the screen. I could delete this this node and put the right one, this one here, but instead of that I will just use this scroll down list and change width to height, and now it should work. Smash, 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 smash. Okay. Okay. It's kind of playable now. Great. So the last thing in this area to do is to make this graph a little bit more consistent. Press Control, frame it, call it reset position. Another task done. The next thing to do entirely here in Unity, so not in visual scripting, is to provide space for displaying the score. This is done by adding a UI item which is called TextMeshPro. Unity asks me to import TMP TextMeshPro Essentials. Absolutely, yes, please. It will take a minute or so. And TextMeshPro is now ready to use. I don't need examples and extras. And now I could... Oh, it's a little bit misplaced at the moment. So I will move it. This is canvas object. Okay, so this rectangle is the object that is displayed as the main asset for user interface, and this new text thing displays the position within the screen where my score is going to be displayed. For now, there is another text, the default text, new text, but this place will be replaced by the score in a few minutes. The TextMeshPro object has to be set programmatically, so by one of our graphs. Now, which one? Player graph or thread graph? The score is 1, okay? We have one central score for the entire game. And we also have a single player, one monster, okay? But several threads. So it seems quite logical that we can use the player graph, which exists in the system only as a single instance, and use it to display the score and also store the score in one place. So let me go and open the player graph. I will first of all add the score variable. Now a few words about types of variables we have in visual scripting. The graph variables, so the variables which we created so far, are local to the current graph. Local to the current graph means that it would be quite difficult to access this score from external place, from the thread. Okay, object variables. To display object variables, I need to select player first of all. Object, by the way, my screen to world point, even though it works perfectly, it's still displaying an error. Probably I would need to restart Unity to get this done, sorted out. So going back to variables, object variable is shared across the current game object. We have only one game object, so it might possibly work, but what we are really looking for is this, the scene variables. The scene variables are shared across the current scene, and you know what? As a scene variable is something that is not supported by C# and C# scripting. So this is a specific benefit of using visual scripting. With the scene variable, I have first to type the name of the variable, score. Okay, this variable will be integer because there will be always integer values. There will be no such thing like fractional score. integer. Okay, so now quickly displaying the score. I will show you another way of sequencing graphs in visual scripting in Unity. We could take the flow from here and continue to set the value of the TextMeshPro object, or we could use my favorite sequence node to create a clear sequence, or we could do even something even else, something even different. We can create another second onUpdate node, which will be executed independently from the first one in the undefined order. So this code which we will create now shouldn't depend on anything created in the upper part. This part of the graph should set text in the TextMeshPro object. So let me find set text in TMP TextMeshPro. It looks great, but from experience I know that this is even better. TextMeshPro UGUI. In visual scripts, always use TextMeshPro UGUI instead of TextMeshPro. Source text with a single argument, this argument will be our score, is the right thing to get. Now it takes 3 arguments. The other arguments are easy. So the first one is the score text, score colon, and a pair of brackets, brace brackets, will be replaced by the argument, the value, which of course has to be our score variable. Okay, so we have set up the argument, set up the source text. It won't work. It will produce an error now because we're missing this value here, the TextMeshPro itself. And to improve on that, I will need a new variable which can be called maybe TextObject, and it has to be of the type TextMeshPro UGUI, as we had it here. TextMeshPro UGUI, click, and this variable will go here and can be easily attached. Now you might say it should work. It won't actually work. It still displays new text, and it still says there is an error in it, and explanation is very simple. This variable contains value of null. Nothing is set. So why it's a rotation? That's okay. Now what we can do, indeed the value of this variable is none, so let's try to drag the actual text object and drop it here, and as you can see, it's impossible. It is impossible because simply graph variables cannot be set in this way. Alright, so this means that we don't need a variable here. We need a variable here which will be available at the object level. So once again, text object, same name, type of this variable will be TextMeshPro UGUI, and now I can drag and drop this value here. So this is my item from the canvas, directly from scene hierarchy, and now still something not working. yes, a small detail, the getVariable function still says that text object should be a graph variable, not the object variable. So I can just change it here, and this should work now. Yeah, I think it works. Score 0. Of course, we haven't yet implemented score increase in the fluid graph, but displaying the score is working nicely. One more interesting fact is that unlike graph variables, object variables are even displayed here in Unity Inspector, so we could also set this value directly like this. The last thing to do is to increase the score each time fluid is smashed. And if you think that it should be done in the fluid graph and down here in onTrigger enter 2D together with increased speed and reset position, this either means that you are right and you have a good understanding of programming, or you just listened carefully to me earlier because I already mentioned that this would be one of the next steps. So let's change the number of sequence to 3 because I will build the new graph somewhere here. Let's maximize the screen so that to have a lot of space. I will rather make a connection like this. Sorry, it doesn't look good. Okay, leaving this output to the increase score code. Increase score code will be very similar to increase speed, with the exception of that we will increase the score variable, not the speed variable, and we will use a value of 1 instead of 0.5. What I can do, I can duplicate this thing, and it didn't go the way I wanted, but I can probably make a block. Now duplicate the selection, and yes, I have it done. So this is a repeated stuff, so this is increase, sorry, okay, increase score, but some parts of this code we can easily reuse. So speed is not a graph variable, it should be a scene variable called speed. Here a scene variable called speed. Addition is great, but instead of float 0.5 we will replace this node with integer literal. Okay, so we don't even have to delete it and recreate it, we can replace a node, and by putting a 1 here we should get the effect. So let's test it. Play, and now smash doesn't work, and I don't know why. Increase score, let me apply this to Apple. This variable, invalid operation exception variable not found, speed. It is scene and speed. I don't know, it should work. It's possible that this is kind of bug in Unity, perhaps. It wouldn't be that strange. Let's test it now. Looks like it should work this time. No, it doesn't look like working. So maybe let's also replace this set variable with variable. Sorry for that. It should work. I need to connect the flow and now set up the oh yes, now I didn't even want to look at it, but by replacing these two nodes everything is working fine. We have the first playable version of the game. It is of course very simplified game and not very funny, but it's now your turn to improve the game. One possible improvement might be with the way in which the score is increased. Right now we increase the score always by 1. We can reasonably easily replace this integer literal 1 with a variable. This should allow to differentiate the premium we get in score when catching various types of fruits, and in particular it could provide a game in which, for example, catching a pear would provide negative score. So you should actually be carefully choosing the red fruits, because catching a green pear would provide you with negative score. So let's first delete the integer literal, and now what we need to do is to create a variable. It cannot be a graph variable because it would be then difficult to get to these variables in different fruits. So I will switch to the object, and in the object section I have two tabs: prefab instance and prefab definition. Prefab instance means that this variable that I'm going to create would be only created for the apple, the single instance of the prefab, and not entire prefab. So instead I will additionally choose prefab definition, type the name of a variable, for example premium plus integer. By default, and for the apple it will have a value of 1, and in this way the variable premium will be visible for all objects created from our fruit prefab. And now the only thing remaining to do is to put this variable here, create a connection, move this object down, and test the game. // no change, of course, everything works as it used to. I have to say I cheated a bit with editing, because again, after putting this variable here, I had a few problems with running the application. Perhaps still some buggy features in Unity. What I actually did, I browsed through these objects here, and I played the game twice before it went well, the second time basically. So in general you may have occasional problems with visual scripting in Unity. I'm not entirely sure if these problems come from something I'm still unaware or I don't know about this technology, or perhaps, which I presume, because this technology still is a bit buggy, uh, but all these problems can be easily resolved. Try to play the game again, try to remove and replace a node which creates problems, and everything should be sorted out. I think that the general amount of benefits from using this technology will overwhelm these minor problems. But back to our main task, we wanted to change the premium for the per, and now nothing could be easier than doing this. For per, the premium value will be -1, sorry, not -11, but technically -11 is also available, whilst it's still remaining 1 for the apple and 1 for the cherry. So let me test whether we have this negative score for the per. So I collected 6 points on the red fruits, and now per, another per, the score is going down even to 0, even to negative values. Alright, I have to recreate my score a little bit. Alright, so this concludes this little tutorial. We have a very simple game with some very simple functionality, and now it's time for you to perhaps try with something more exciting than this. Thank you very much, and don't forget to subscribe to my channel.